So if you want to know why our colors are green and white, it's because Dr. Phelan is a Boston Celtics fan. Boston Celtics, baby, that's why. I never thought we'd get this close. We even 6 years ago in the last meeting, we were saying, well, maybe not in our lifetime, but, we're going to get there. Maybe a cure for this rare neurodevelopmental disorder is just amazing to me. I mean, I think we're so close. Somebody will come, their first meeting, they spend part of the time in their room crying, but by the last day of the meeting, it's like a family reunion, except they like everybody in their family, and they're crying, when are we going to see you again? We don't want to wait 2 years, this and that. And it's just, I love it. Yeah. I'm glad I'm part of this family.
Welcome. I'm Ron Kleiman, and this is Generation Hope. Today's guest is Dr. Katy Phelan, a pioneering human geneticist, the founder of the Phelan-McDermid Syndrome Foundation. In this conversation, recorded at the Phelan-McDermid Syndrome Foundation Annual Conference in 2024, Dr. Phelan takes us back to the earliest days of how this syndrome was first identified, how families found each other long before social media, and why community became the turning point for so many parents. And we talk about what's giving families real hope as research and treatments move closer. As a dad to a 15-year-old girl with Phelan-McDermid syndrome, this conversation meant a lot to me. If conversations like this are helpful, please subscribe, like, and share. It's the best way to support Generation Hope. And now, Dr. Katy Phelan.
I'm Katy Phelan. I have a doctorate in human genetics. I'm currently the director of genetics at Florida Cancer Specialists in Fort Myers, Florida. I am a founder of the Phelan-McDermid Syndrome Foundation, and I started the support group.
So what I've been asking everybody is kind of start with their origin story.
Well, I was a biology major. I grew up in Jacksonville, Florida. I'm the sixth of 12 children. So I come from a big family, middle child, under the radar, flying under the radar. My father was a physician, and we're kind of a medically oriented family. So in high school, I was always a science and math nerd, even though my 10th grade teacher told us that the girls were not equipped to do math and science. We were not going to do as well as the boys. Our brains were not built that way, and we shouldn't feel badly about it.
Okay.
So when I aced my first geometry test, and she called me up there and told me this wouldn't happen again, because I didn't do so well on biology, but I aced the geometry. So she was telling me that the geometry wouldn't happen. I said, no, I'll never do that poorly on biology again. You're wrong. So yes. So that was, I knew that I was going to do something in science, right? So I went to college, Spring Hill College in Mobile, Alabama, small Jesuit school. I majored in biology. And after I graduated, I knew I wanted to continue my education. And so things happened to me just because I stumbled into them. I don't have a plan, right? So I thought, well, what did I like best in college? I liked genetics and microbiology. So which one did I like better? I liked genetics better because it was so mathematical and logical. Which, of course, it is not mathematical, but that was my impression. So I think I'll go to graduate school in genetics. And that was how I made my decision. I like genetics better than a little more than microbiology, so I will go into human genetics. And that's what I did. So I went to the Medical College of Virginia, get a doctorate in human genetics. And I chose Medical College of Virginia because I looked at graduate schools in the Northeast. I was looking particularly at Boston because I'm a Boston Celtics fan. So if you want to know why our colors are green and white, it's because Dr. Phelan is a Boston Celtics fan.
That's that's really, I'm sure that's going to blow a lot of people's minds.
Yeah, so people have asked me over the years, because you're at Greenwood? Is it because you were too late? No, Boston Celtics, baby. That's why.
Yeah, right here from the source. That's amazing. That's why.
So I decided I couldn't go too much snow in Boston. I'm not going there. But I could go in Virginia. I go to Richmond, because then I could go up to Washington, D.C., Landover, Maryland, those days when the Celtics played the Capital Bullets, or whatever they were called. And that's exactly what I did. I would watch the newspaper, and when the Celtics came, I would drive up there and see this. That's like I say, I stumble into things for stupid reasons. That's what I did.
But it's worked out for you.
It's worked out. And then I did a postdoctoral fellowship at the Greenwood Genetics Center, and they invited me to stay and direct the cytogenetics lab, which I did. And after I'd been there 4 years, how many years. We did chromosome analysis on a newborn that Dr. Rogers and some other geneticists evaluated the baby in the newborn period, newborn with hypotonia, and did chromosome studies. And I think out of the 4 geneticists who saw him that morning, 3 of them didn't think he needed chromosomes, but Dr. Stevenson said, yes, we should do chromosomes. And the baby had a little tiny deletion of chromosome 22. And so I was the director of the genetics lab, and I had not seen that before. I guess not many people had. And, I looked in the literature, and we decided to present it at a meeting. This was in May of '88. Okay. We presented it that fall at the American Society of Human Genetics meeting. And then we decided, well, we should publish this. So that's when I contacted Heather McDermott, because I knew she had published on chromosome 22. Okay. But she had published on cat-eye syndrome, which is a duplication of 22.
Right.
Chromosome 22 is chromosome 22. So would you do molecular studies on this patient with deletion of 22? And she agreed. So that's how we, Phelan-McDermid, connected. I guess I probably telephoned her and asked her if she would do it. And that was the beginning of our collaboration.
How does it feel to, have, your name on a disorder that affects so many people, but it's also people have been able to kind of build community around it?
I look at it and I don't think of it as being me or my name. It's kind of, it's beautiful to see the families. I love seeing them. I love the kids and the siblings, especially love the siblings, and watching the children grow and seeing them now after not seeing so many kids for 6 years. I just, I love to see them, and a lot of them recognize me, some of them don't, but I love to see the kids, and I just don't think, oh, look what I did. I started something, and Dr. Rogers and the family and the parents took off and ran with it, and that's a great thing. The families support each other so much, and we have families, I don't know about this meeting, but other years somebody will come, their first meeting, they spend part of the time in their room crying, but by the last day of the meeting, it's like a family reunion, except they like everybody in their family, and they're crying, when are we going to see you again? We don't want to wait 2 years, this and that. And it's just, I love it. I'm glad I'm part of this family.
me too. It's an amazing experience. Yeah, are your other siblings in medicine too?
I have a brother who's a retired physician, a couple sisters that went into nursing, some other ones that went into other fields, a sister that's a chiropractor, another one that works in a dentist's office. So most of them have some connection to the...
You guys should open up like a little, center for everything.
Yeah, my father always thought I'd come back to Jacksonville and open a genetics lab. I was like, it's not that easy. Just move and open a genetics lab.
Following everything that's going on with genetics over the years, what's possible with genetics? And
I'm not a basic researcher. I'm a cytogeneticist. So my interest has always been diagnosis and advancing the clinical knowledge about the features and things that can immediately help the family. So I'm not like a basic researcher, animal models, curing the disorder, things like that. So I'm more into helping the families, raising awareness, educating the medical community. And I never thought we'd get this close. We even 6 years ago in the last meeting, we were saying, well, maybe not in our lifetime, but, we're going to get there. And I always thought, well, when there's gene therapy for, say, Parkinson's disease, then maybe we can ride the coattails of that. But to get the, maybe a cure for this rare neurodevelopmental disorder is just amazing to me. I mean, I think we're so close now.
It certainly feels that way. Especially, speaking with grouping who's kind of on that side of it. Yeah. It was very, I tried to temper, excitement. And it seems just like such a roller coaster ride of it's coming, relax, coming, it's not coming, it's coming, it's coming. But it certainly feels like with all the work that's being done in the area, it's just a matter of when.
I'm very optimistic about it. I'm really excited.
So when you guys found the deletion of chromosome 22-13 through chromosome analysis, what is that process like? Is that still used, or is just easier they just do exome or genome or microarray?
Probably the first tier testing in most labs would be a microarray.
Right. And can you explain what a microarray is?
It's a molecular cytogenetic technique where you're looking at copy number variation to look at gain or loss of genetic material. So you're basically probing along the whole length of the chromosomes and comparing it to a reference sequence to see if something's missing or absent along the chromosome. But you're not looking at the structure of the chromosome. Okay. So if there's, say, a missing sequence, it's missing, right? But if it's extra, you don't really know where it is. It's just
there's an extra. Yeah.
So you could pick up a deletion easily because the bottom of chromosome 22 is missing. But if there's an extra piece of chromosome 8, you don't know where it is. So is it a translocation that's on the 22? And then you should look at the parents and whatnot. It doesn't really tell you the structure, and it doesn't pick up a ring chromosome.
Right.
So that's why we say if you've had a microarray, your child's had a microarray and has a deletion of 22, now you need chromosome analysis to see whether your child has a ring or not.
Back then, what did that process involve in terms of how much time and effort did it take to run that analysis?
Well, for chromosome analysis, a sample of blood, you culture it for 72 hours, and then you make a slide and you look at the chromosomes.
Literally looking at it with a microscope.
Right. In the old days, now we have computer ability. So now most labs have a automated scanner. So you drop the slide, takes about all morning to go through the process of harvesting the cells, staining them, putting them on a slide, and you put them on a scanner, scans the slide, captures the image, sends it to a workstation, and you can look at the chromosomes that way.
Okay.
And then arrange the care. You used to take a picture of it, take it to the darkroom, print the film, cut them out, arrange them on a board. It's very time consuming, but now we can do that in automated fashion.
Is pretty much the whole process automated that you just described, or is it like for scraping a slide? And
there are systems that would drop the slide and do things like that, harvest even for you. My techs don't like that. A lot of labs don't like that. Like some of the big, larger commercial labs that have a high volume and maybe work 24 hours a day, have different shifts, they like that automation. My lab doesn't like it. They think they are better than a machine.
Right.
So, just the preference of the lab, I think, and the hours and the caseload. We do everything except the karyotyping by hand.
So you found a missing chromosome, and then you published your paper, and then what happened?
Well, we we presented at a meeting that year, and then we did further studies to characterize it. We published it in 92. So I was the lead author. Dr. McDermid was on there, Dr. Rogers, other geneticists from Greenwood. And I was the lead author on the paper. So once it was published, the parents would start contacting me. And it wasn't, geneticists, it wasn't genetic counselors, it wasn't other laboratory geneticists. It was usually always the family, usually the mom would call me or write to me and say, my child has this, what can you tell me? So I would contact the family we had in Greenwood and say, oh, well, there's somebody in Ohio whose child has this, and they want to know, what is your son doing now? And does he chew on his clothes? Does he do this? Does he do that? And so I was learning about the features by talking to the families. And, this family in Ohio wants to talk to you. Can I give out your number? So I found out that, the family in Greenwood says, give my number to anybody. So I was putting families in touch with each other, and I was learning about the features. And what I was learning from the families was they didn't like being called deletion 22q13 syndrome. Mm-hmm. They wanted a name like Down syndrome.
Yeah.
They wanted a name. And they wanted to meet other families. So over the next few years, I had 9 families I called my telephone buddies. I don't mean that to be in a derogatory or patronizing way, but they were my telephone buds. And I'd put them in touch with each other, and it was always, we want to meet other families and we want a name. So I had the opportunity to write a grant for the cytogenetics lab at Greenwood. And this is how it is when you work in a small, community center like this. Greenwood's a huge center now, but, in the small town. One of our geneticists was playing golf with his brother-in-law and another man, Bill Danielson. And Bill's son had a chromosome abnormality, and they have a foundation, the Michael Foundation, named for his son. And Bill told our geneticist that if the Greenwood Genetics Center submits a grant to the Michael Foundation, we could, look at the grant and maybe fund your center for something. So Roger Stevenson said, well, since the child has a chromosome abnormality, it should go to our chromosome lab. So Katy should write the grant. Okay. So I wrote the grant to have a support group meeting. So I said, well, I know these 9 families that have this rare condition. Nobody can help them. We should bring them to Greenwood and teach them about this disorder, which we don't know anything about either, but we could do clinical genetic evaluations. We could learn about it, and then we could teach them about it and teach everybody else about it. And it just, in the recent years, it has begun to astound me that the director of the center didn't say, are you out of your mind? You're going to fly all these families in here and teach them about this condition? But, okay, that sounds like a plan. So I wrote a grant, and the Michael Foundation gave us $20,000. We didn't fly the families there, but we paid for their room and their board and all the presentations, everything. And they just had to get to Greenwood, and we paid for everything else, or to Greenville. We had it in Greenville. And we paid for everything else. And we had 23 families that we knew of at the time. By the time I knew of 9 when I hatched this plan, but by the time we had the meeting in August, I knew of 23 families because everybody kind of knew somebody else, So 21 out of the 23 families registered for the meeting. One of them didn't show up, a South Carolina family, I should add, although we were in South Carolina. But so 20 families came to our first meeting, and we decided that we'd meet every 2 years on even number years, and we launched a plan to have a newsletter. We had a photo directory, so we had everybody send in pictures, I guess ahead of time, and everything was by mail and post. I had like self-addressed stamped envelopes for people to fill out. What date are you getting here? How many people? Do you need a babysitter? Do you have special dietary needs? And they, checked off the postcard, mailed it back to me, so we had everything figured out. They arrived, and that's how we did it.
That was the beginning of the family.
Yeah, and I guess they sent in photographs because we have notebook, we had binders that we put out that had everybody's name and address, pictures of their kids, like collages with different photographs. We did that for many years.
Do you remember what that first meeting was like?
Oh yeah, it was great. It was so much fun. We'll show a picture of group because we took a group picture. We took one of just the kids. They were like, "Are you a kid? We're going to get these kids." Yeah, take a picture of the kid. Then we had a picture of the families and kids. Yeah. Well, it's fun.
It just grew from there. Every year, every 2 years.
Yeah, we had like 20 families. The next time, 2 years later, we had 40 families. Then we had 60 families, and then we had the hundreds. Yeah, it grew. And our first meeting in South Carolina, we met at the Embassy Suites because one of Curtis's genetic counselors, Gail Stapleton, and I were checking out where we could stay. And the Embassy Suites had a shuttle bus from the airport that was free. They could accommodate. Can you accommodate wheelchairs? Can you accommodate? Oh yeah, we can do all that. We can do all that. And they had free breakfast, free happy hour, free this, free that. So, and they had suites, so the whole family could fit into one room, and they could fix their own meals. So we could do this. And they knew us from year to year. The families would say, we come in this year, and they say, "Does your child still need their food pureed? Do they still need?" So they knew it was great. We just outgrew it,
Sure.
After years. But our first year there was another meeting there. I think it was called the Carolina Sugar Babies. It was a beauty pageant.
Okay.
So mostly it was little girls, but it was also some adults and some boys were concerned. So the kids in the beauty pageant, were in their little fuzzy slippers and their hair rollers and their makeup. And then there was us.
Oh my.
We're not sure who needs more help, us or them.
So one of the things that I want to talk about is the diagnostic journey. There are some programs in the U.S. which are more either charitable programs or some private programs where if your child ends up in the NICU for any particular reason at all, they offer a free whole genome sequencing. How do you feel about diagnosing like a whole genome sequencing kind of early on?
Well, I think any child with developmental delay, a diagnosis of autism, neurological disability, hypotonia, they need a microarray and or next-gen sequencing, whether they do a whole genome or an exome sequencing. They need sequencing and they need a microarray, whichever one you want to do first. If that doesn't pan out, do the other one. Right. So I said most labs will start with a microarray. Some labs will start with sequencing. Is that, you go on to the next one.
Is that based merely on cost? Microarrays are cheap or easy?
Preference.
Okay.
So when we did the guidelines for that Sid talked about this morning, we sort of said, most labs will do this, but some labs start here. So it's just, I think a laboratory preference, but I still think that most people would start with a microarray.
But it would be, you may not get the answers you're looking for. It'll give you deletions, but it won't necessarily
give you like the pathogenic variants of Shank3.
Right.
You need the sequencing for that.
What do you think is the barrier? Do you think it's a cost barrier? Or do you think there's an ethical barrier?
I guess reimbursement is a problem if you don't get
for costs.
Yeah, reimbursed for the study. So if people don't have insurance, in the U.S., I guess having the ICD-10 code will help.
So in Canada, it's very different. It's really interesting. Everyone I'm speaking to, there's everyone's kind of based in the U.S. and the conversation always turns to insurance, where that actual conversation we don't have. There are other conversations that we have in terms of timelines and access to care and things like that. But there's never a question of who's going to cover this. It's just if it needs to be done, it gets done, not necessarily as quickly as it should get done.
Yeah, and that's a problem in the U.S. because a lot of families can't afford it. But the actual cost, I don't know what the cost of a microarray is now. I know the cost is coming down, but like in a chromosome analysis, I mean, that was a test we had in the 80s, right? Before we had FISH and then before microarray was widely used, we had chromosomes. But you had to have a really big deletion, like 5 megabases or bigger, to see it by chromosomes. Okay. And even at that, a lot of people are going to miss it because they're not looking that closely. I mean, I saw a deletion that 5 other labs had missed.
Wow.
But I talked to the dad and I said, well, the daughter had a diagnosis of atypical Angelman syndrome. And I was talking to somebody at a meeting and I said, well, if you have that diagnosis, you ought to think about this deletion of 22q. It was before it was named Phelan-McDermid. I said, you ought to think about this because they have similar features, except, And then this dad was like, well, my daughter has that. And I said, well, what do her toenails look like? Oh, yeah, they're thin and flaky and they don't grow. I was like, oh, yeah, you need to think about this. And he sent me the blood. And I was like, oh, that's a big old deletion.
So now we're in this period of, excitement with the gene therapy.
Yeah.
Do you get a sense of families of who would be interested in doing this?
I haven't heard anybody say, I'm afraid. Mm-hmm. I'm afraid. What if this happens to my child? What if? I mean, it's more like my child might be too old. This might not help my child because they're too old.
Right.
So it's more that kind of concern. Maybe they wouldn't say, maybe people who are afraid are not going to say, oh, I'm afraid it's going to cause my child a brain injury to my child. I'm afraid it's going to cause an infection. Mm-hmm. I've never heard that. I've heard, I'm afraid my child's too old for this to help them. So I've never heard any other kind of hesitancy like, who would do that? Who would inject something in their brain? Never heard that.
Mm-hmm. Well, there's lots of studies going on where I know with one in Rett syndrome where they've already kind of started that same process of the ICV injection into the brain. As far as I know, everything's still moving with that trial, so things are going, I guess, well enough to continue the trial there.
I think the parents are enthusiastic and optimistic, and there's so many new families here. That's amazing to me, how many new families. I don't know if it's just the opportunity to be here because we're in a different area of the country.
Right.
And it's given more people that weren't able to go to Florida or to Texas an opportunity to come. But I think that's great too. So many new people.
And so from that original group, there's so the panel that you're on this afternoon, it's you and it's Curtis, who's also we're speaking. Sue Lomas, she's one of the original six families or 9 families.
Well, I don't know if she was in that group. I don't think she was. I think she came to the meeting because she knew another family from Florida. Nick was definitely one of them. Nick, I don't know if I talked to Sue in that first group. She came to the meeting, but she didn't think she belonged there because your son was so young and cute.
Were the other patients a little bit older?
No. The oldest one was 26, Eric. Then we had a 15-year-old, and everybody else was under 10.
Okay.
They were all very young.
Right, because they would have to be because they just got chromosome analysis, and that was that how new was that technology?
Well, chromosomes have been around since the late 50s.
But they wouldn't necessarily do a chromosome analysis
on somebody who was physically not particularly dysmorphic looking.
Right.
So they're typical, most children are typical looking, especially in the young age, right?
Yeah.
And maybe they have poor muscle tone. So they're seeing in a neurology clinic and they think they have cerebral palsy, or maybe they have an autism diagnosis and they're not going to do chromosomes. So I did we did questionnaire data. So we started collecting longitudinal data at the first meeting. We had questionnaires. We thought we were so smart. We had a health questionnaire, a medical history questionnaire. We did the clinical exams. And we asked them about what lab work they'd done. And about a third of them had chromosome studies more than once before they got the right diagnosis. Because it was missed. Some of them had prenatal diagnosis and it was missed.
Oh.
It's because it's hard to see. You have to have long chromosomes to see a really small deletion. And if they just did a routine analysis, they're going to miss it. So about a third of them had chromosomes 2 or 3 times before it was picked up. And the most common diagnoses before it was the deletion of 22 were cerebral palsy and autism. So they were misdiagnosed. And you're not going to do chromosomes for cerebral palsy, right? You don't expect to find anything, especially back then. Now, and in autism, they worked on chromosomes. There were some, a neurologist was following them. They don't do chromosomes. Go see a geneticist for that. Now they do, but then I think we started the group in '98. I think eventually somebody else would have started it if we didn't. The parents would have started a support group, but I think the Greenwood Genetics Center was a unique place. There are many probably still more clinical geneticists per capita than any other city in the world. But I think it was a very unusual opportunity to start something, and they were very supportive. We had the grant from the Michael Foundation. Greenwood provided the rest of the money to put on that meeting. The clinical geneticists all showed up to evaluate the children and do the physical exams and to talk to the parents. We drew blood. Heather McDermott was there. She took samples back with her. I think we might have kept some. In other years, we kept some at Greenwood and studied them. We had the staff of the Greenwood Genetics Center were our babysitters. I mean, we were very, mom and pop. We didn't have formal paid babysitters or anything. The, technologists, the clerical people, everybody else were our babysitters. I had to stay with the kids. It was,
I'll say it makes them, definitely it makes them part of it. Right?
Yeah, I mean, everybody was very engaged with making that meeting a success. And for the next few years, till we decided, well, there's probably some liability here we need to think about.
You must travel around a lot.
Yeah, it was the pandemic put a little bit of a damper on that. But yes, I've been to a lot of places to talk to a lot of people about Phelan-McDermid syndrome.
Do you cross the pond? Do you go to Europe as well?
I've been to Australia a couple times. I've been to Norway and London and Paris and Milan and places. Sue and I once took a 19-day trip to go to Paris, London, Milan, and Madrid. And we worked every day those 19, except we weren't traveling. I think we had one free day in Milan.
Okay.
The rest of the day, you'll be in Paris 4 days. Well, this day you can meet with the teachers, then you can meet with the doctors, and then you can meet with the educators, and then you can meet. It's like, well, how about sightseeing?
Yeah.
No.
Give us a couple hours.
We're here. We always have our schedule packed when we travel.
How would you categorize, or how would you kind of describe, is it different, the families and the education and the support systems in the different places?
It's very different. When we went to, maybe the first time we went to Paris and we talked to the families, a lot of times we'll stay with a family when we travel internationally, which is interesting. We'll stay with one of the families. And when we went to Paris, one of the people asked about our budget in the foundation and how we had the money. And we said, well, the parents, raise the money, or we donate and this and that. And they said people don't donate to charities. Maybe I have this wrong now, but they were saying that they don't just say, send in money. People aren't going to donate, and how difficult the fundraising is. Like, where do you get your money? And it was like, well, parents have fundraisers and all this, or we write a few grants. But back in those days, it was all, parent funded. Mm-hmm. They were like astonished they would have this much money from donations.
It's not part of the culture there.
Yeah, that's not how they do things. It was like, well, that's how we do things. Yeah. You have to be generous and give money and things like that. And the other thing I noticed when we went to Norway the last time, a lot of the kids were just, verbal and walking around. They were very high functioning. Curtis and I were like, where are the other kids? Where are the ones that are in the wheelchairs and that aren't talking? We never figured that out.
They were like, all the PMS kids were all like high functioning.
It's weird.
I'm sure there's something there.
I know. It was
There's something there to look at, probably.
And then when we were in March, we were in Toronto, and about half of them had Shank3 variants. Whereas in our group in the data hub, I think it's only about 86% have mutations and 14% have variants. So the percent with variants is really low.
Can you clarify that for me? The difference between mutations and a variant?
I'm sorry, deletions versus variants.
Sorry, gotcha. Okay, gotcha.
So 86% have physical, like misdiagnosis of chromosome 22, and 14% have Shank3 variant, have the gene variant.
And in Toronto, it was...
So it's almost half and half. So I think it's because not everybody's getting sequencing. So once we get everybody's getting sequencing, we're going to have a high number of variants that we don't see now because people don't have access to testing. Another difference that we see everywhere is the racial difference in testing, and that's definite accessibility to testing, that some racial groups do not have access to testing, that we need to see that even out.
Yeah, test everybody.
Yeah.
Yeah, absolutely.
It might be a mistrust of the medical community of some people, but we need to get access to testing for everybody, regardless of their race or socioeconomic status. That's a big problem.
That's interesting.
And it's the same thing with autism not being diagnosed in some groups, and it should be diagnosed. There was an international genetics meeting in Australia, 2006, so they kept telling us to come over. And I said, okay, we're coming over for the international meeting. If you have a family meeting back to back with that, we'll be there. So the international meeting a genetics meeting was in Brisbane. And so, but we had a family in Melbourne that wanted us. So we said, okay, come have a meeting and we'll go to Melbourne first and then we'll go to Brisbane. So we did that. So sometimes we try to, connect it to somewhere we're going to be anyway. One thing I'm going to talk to Kate about is the Shank3-unrelated population.
Shank3-unrelated?
Yes. So the people with interstitial deletions that don't involve Shank3.
Okay.
So was it January of 2022, 2020? I don't know. Me and Curtis and there's about 12 authors, including Thomas Bourgeois and Tobias Beckers, who described the Shank3 gene. In Europe, they call it ProSAP2.
Okay.
So I think Thomas Bourgeois, especially in Paris, and Tobias Beckers in Germany, they sort of, discovered the gene or described the gene or whatever. And then it was found to be related to this syndrome, Phelan-McDermid Syndrome. And so they are authors on this paper, and there's, like I said, a total of 12 authors, a couple of parents. And so we said, well, when we first described the deletion and we did our meetings and we collected data and we had people that had terminal deletions, the end of the chromosome, and interstitial deletions, and we didn't know about Shank3. And they all had Phelan-McDermid syndrome, right? And then when Shank3 came along, and the autism people came along, they said, oh, you have to have a deletion of Shank3 or you don't have Phelan-McDermid syndrome. And I've always said that isn't true. You have a deletion of 22 and you have Phelan-McDermid syndrome regardless of Shank3. But autism people are adamant about it's all about Shank3. So 2 years ago, we published this article, me and Curtis, who started the support group, and the people who discovered Shank3 discovered Shank3 said we're categorizing Phelan-McDermid syndrome into Shank3 related and Shank3 unrelated, so that we're not going to exclude anybody, because historically, when we described the syndrome, we included everyone as a deletion of 22q13. And so we are not going to exclude these people that don't have Shank3, right? Because they have the same phenotype. They have intellectual impairment, they have absent speech, they have ataxic gait, they have sleep problem, they have all these same features. They have the same syndrome, but Shank3 is not deleted. So we need to study them and characterize what they have, because nobody's including them in the study because they want it to be all about Shank3. So we need to...
So there are people who have their Shank3 gene fully intact,
but they have the same features as other people with Phelan-McDermid syndrome, because they have a deletion of 22q. So there have been studies where people have characterized what other genes are on chromosome 22 that give the same phenotype as Shank3. So there was a paper recently. Audrey Thurm is one of the authors. She's at the NIH. She's here. saying these are some other genes that could have the same phenotype as Shank3. So they could lead to that same phenotype, that it doesn't have to all be Shank3, right? So I think we need to look at those people and say, look at them closely as a group and compare them to the Shank3 related as a group and see what are the differences. Because there was even a publication that said this is a different syndrome because it's got the same deletion and the same features as Phelan-McDermid, but Shank3's there. It's like, yeah, it's Shank3 unrelated. I mean, it's Phelan-McDermid, Shank3 unrelated. It does have the same features. It looks exactly like Phelan-McDermid because that's Phelan-McDermid, but Shank3's there. The largest deletion in Phelan-McDermid includes, I think, 211 genes, the largest deletion. So this is an article that's by Andy Mitz and Audrey Thurm that came out earlier this year because we told Curtis he had to talk about it in Toronto. He mentioned this article that had, I think it was 211 genes and what all might contribute to the phenotype besides Shank3.
So with somebody like Evie, who's got just a single point mutation on Shank3.
Yeah, so we wouldn't expect her to have like lymphedema because that's a different gene, or kidney problems because that's a different gene. So we wouldn't expect her to have all those other features that people with a bigger deletion of 22 or an interstitial deletion, where they would have. We wouldn't expect her to have those other features.
Okay. Interesting.
And even people with a small deletion of 22, we don't expect them to develop lymphedema or kidney problems or other things that map farther out on the chromosome.
So when there's a large deletion, it's always a large deletion on that chromosome.
Yeah, but there's more, because there's more genes and you have more phenotypic, like there are probably genes for cardiac abnormalities, things that are farther out there that are going to be affected. And what like they were talking about, somebody will say, oh, I have Phelan-McDermid and my son has it, and then I was tested and I have the deletion. And I'm like, okay. And I've talked to some of these parents, and it's always an interstitial deletion.
So they have Shank3, but they have
a variant of Shank3, but it's an interstitial. Or no, it's not a Shank3. It doesn't include Shank3.
Right.
It's a variant, but it's like it's a deletion. I'm sorry, it's not. It's an interstitial deletion that does not include Shank3.
Gotcha.
So I think those people are mildly affected compared to if it's a small enough deletion. So that's another reason I want to look at this population. I know Kate's only going to be there another week or something. I'm going to say, you need to email these people and tell the people with the interstitial lesions to email me because I'm going to look at them and say what.
It's going to be sad to see Kate go. She's done a lot.
I know.
I'd like to thank Dr. Phelan for taking the time to speak with me and share her story. It really does feel like we're on the cusp of change with a gene therapy and ASO trials already in progress. None of this would be possible without the work the Foundation and its families, researchers, and supporters have put in over the past 30 years. So I want to offer a heartfelt thank you. Because of all of you, the future is brighter than ever. Be sure to check out our other interviews with top researchers, doctors, and advocates working to bring therapies and ultimately cures to rare disorders. And if you found this interview helpful, please subscribe, like, and share. When you subscribe and turn on notifications, you'll get alerted each month when a new interview drops, along with updates from Generation Hope. Till next time, stay hopeful.